First, let's try to interpret this picture. We've got a velocity time graph. The object starts with a velocity of 4 and increases its velocity to 24. That means that I actually threw it down at 4 meters per second, and it increased until such time as it hit the ground. On hitting the ground, we land up with it doing a bounce. And the bounce is this entire space over here. So this is the hit of the ground. And although I'm only in one spot, this is my rebound. Then what happens is the ball goes up in the opposite direction. So now this ball is going to go up there until it reaches a point where it doesn't get as high as it was before. So maybe, anyway, it then gets up there and then it stops. C is where it stops, and then it continues in the opposite direction from C to D and comes back down to the ground, and then it hits the ground. So at D, it hits the ground again. Okay. So that's pretty much the picture of what's going to happen. I gave it a velocity to start with, which is 4 meters per second. Okay. Or not I, but the person. So let's try and interpret what the questions are that they're asking. At which point on the graph, A, B, C, or D, did the apple hit the ground for the first bounce? Hit the ground over here at point A. At which point on the graph A, B, or C did the apple reach the top of its first bounce? That's at stop moment, so that is C. It then asks you to describe the motion between B and C. So between B and C is this part over here where the object is bounced off the ground and is going up into the air. So it is slowing down at a rate of 9.8 meters per second squared, and then it stops at the top of its projectile at point C. Use the graph to calculate the height relative to the ground from which the apple was thrown. In other words, this height over here, we've got an initial velocity of 4 meters per second down. We've got a final velocity of 24 meters per second down. We've got an acceleration of 9.8 meters per second squared down. And I am trying to find a displacement, so I'm going to say v squared equals u squared plus 2as. I suppose that I could have used the 2 seconds as well if I had wanted to, and I'd get a slightly different answer because of that 10 on the gravitational acceleration situation. So let's look at that. If I substitute in, I get 24 squared equals 4 squared plus 2 plus 9.8. I've just used positive for down all the way through. S, and S then comes out to be 28.58 meters. If I had used the 2 seconds and not the acceleration, I would have got exactly 28 seconds, at least 28 meters. And if I used the area under the curve, I also would have got exactly 28 meters. Last question, draw a displacement time sketch graph to represent the change in position of the apple for the same time period given in the velocity time graph. No values, but the positions A, B, C, and D need to be clearly marked. Take the ground as your frame of reference. So I must start. Frame of reference means that has to be the 0 point. So here we go. 0 is the ground. I start, remember, up 28.28 meters. And that is my displacement, measured in meters. My time is in seconds. And I fall down until I hit the ground after a certain period of time. And I happen to hit the ground at 2 seconds. I then bounce back up, not as high. Okay, you can see it's not as high because I don't get the same amount of speed or anything like that. And then I come back on myself again. So that's the top of the projectile. That's the end of the journey. This is A and B simultaneously. It is the beginning and the end of the bounce.